Good evening, everybody. So, in our previous lecture, we were discussing how to implement a stack. Okay, I discussed with Java program, and if you go to my GitHub account, and you will see that I have a C# solution project. Okay. It's a CSE1322 review C#. So if you clone this project, you see that I have a number of projects in this C#, this folder. So maybe I've been pushing for more than a year. So if you clone this project, you will get implement stack, this project. So it has node.cs class, and it has stack. So let me open it in Visual Studio. So this is my project. So it has node.cs program, CS file. So namespace name. So how many you are taking? Patrick, you are taking C# lab, right? How many of you are taking C# lab? Okay, I think you know already what is a namespace and how to create a C# solution and project, right? Okay, so this is my all of my projects. So if you download my repository, then you will see all of my projects, a number of projects I do have. So the node class is simple. So compared to Java, I just add access modifier public over here, and everything is same except, and then I replace system.out.println with console.writeline, and then this is same. Okay, and the stack class, that is also same, and the program here, this program's class is the main program over here. So if you see that I have this program, if you run this program, this is my output. So no matter which language are you taking for your lab class, you need to practice this. When you start practicing, you will get some issue. Maybe you will find some issue and you will understand in depth. Yeah, so please practice, and then if you feel any issue, then please let me know. Okay, and if I go to our official slides, I missed one thing. This is called Doubly linked list. This slide. Maybe in my project I should have implemented Doubly linked list. Should I have Doubly linked list? Implement singly linked list. Maybe in my Java project I should have Doubly linked list implementation. Let me see. (1322) review Java. Okay, I have Doubly linked list implementation in Java. So let us run this program in Java, and then I will convert it into C#. So the node class is almost same, except that it has an extra node. So previously in our singly linked list, we have only one node, inner node, but in our doubly linked list we need two link object, node objects, one for previous, another for next. In a doubly linked list, every node knows who is forward to him and who is next to him. So this is why we need two nodes here in my node class, one for next, another for previous. Okay, and then other implementation, and then for instance the node constructor will be same, but our implementation will be a little bit different, since we have two node elements. So we have, for instance, node head and tail. Okay, by the way, I have in this program I have used size variable to implement or to find whether a linked list is a linked list is empty or not. Previously we showed that if head dot next equal to null, or if head equal to null, then we say that in a previous singly linked list. In our singly linked list, let me open singly linked list open parallelly. Okay, in our singly linked list, we checked whether our linked list is null by this way, if head equal to null. Okay, we can do another alternative way. For instance, if I say that if size is 0, then we can say if size returns the linked list size, and then if size is 0, then definitely the list is empty. It is true. You can implement this is empty method for singly linked list and doubly linked list, both way. Okay, so maybe I implemented just a different way to give a heads up. Okay, and it has the prepend method and append linked list. It has prepend method and append method. Okay, so in prepend method, so we need to check whether head is null. The head is null, that means there is no element. Then okay, so then we need to do head dot previous equal to temp. We need to put this value head dot previous in a temporary location. Okay, so then and we on head position we need to like actually this, and we need to put head equal to temp. Actually this is a multi-line code. I just blocked in one line. Okay, that is if head not equal to null, that means if there are some elements over there, then we need to change head. And if it is tail equal to null, or even I could say either here head equal to null, either I could say head equal to null, either head equal to null or tail equal to null, because if my list is empty, linked list is empty, then for doubly linked list both head and tail are null. Initially for doubly linked list we are making both head null and tail null, and initially size equal to 0. So here you can check either head equal to null or tail equal to null in order to check if your list is empty. Or you could say size equal to 0. Or another way you could say is empty equal to true. Then there are multiple ways that you can implement this line over here, condition over here. Okay, and this is the prepend method and this is the append method. Okay, and prepend method and append method, these are different, and I have iterative forward and backward. I have remove last, remove add, all methods. I don't have search method, but if you want you can implement search method, by looking in singly linked list code. Okay, but for your test, you don't need doubly linked list search method. But please review prepend and append method for both singly linked list and doubly linked list. So in our slides, we have a doubly linked list slides. Let me open this. So the main concept is that in a doubly linked list, every node contains two things. The arrow means it knows the who is next and who is previous. I think same thing. Insertion at the beginning, insertion at the middle, insertion at the end. So let me see the slides. How many slides we have? So this slide shows how to insert a node in middle. What it is adding a node at the end is easier than adding at the middle or adding at the beginning. These are the slides. This one, it says how to add in the middle. Let me see how many slides are we have. It has delete and C# doubly linked list node. Okay, this has some code snippets, but I'm not sure that this will work. But I have my own programs. I believe I tested and these are working. Let me run this program. Let's see what do we have here. Okay, and this is my main method. In the main method, I just created a doubly linked list DLL object, and initially when I create DLL, the size is 0. So if I check DLL.size, they are printed 0. And I have my append method. If I want to append a node with ID 1 and name A, so then I appended this. My append method is implemented. And then I added A, then B, C, D, and E, and then I have my display method. If I call display all nodes, and then it would display all nodes. Okay. By the way, in this program I have some append and some prepends. Let us give attention what does it has. What does this do? So if I say append A1, so that is the beginning one. So that will be the top element, right? So in this case, okay, if I say append, so in this case A will be my top element, and if I say append to, so then let us think that this side, left side is top and right side is bottom. So then B will go here and then it will come this way, and I'm sorry, if I say append, so this side B will go this side. And if I say prepend 3, then C will come in front of A. Okay, and then if I say append 4, then 4 will come here. 4 is D. D node will come here, And again, if I say append 5, then 5 will come here. 5 will be here. So who is my top element here? 3, right? Next is A, B, D. Oh, I'm sorry, this is 5 is E. Okay, C, A, B, D, E. So if I display, then it will come, it will display C, then A, then B, then D, then E. Okay, so when we consider C, let us see who is the previous node to C. Is null, right? So C is the top element. Okay, and so how do I say that? How do I find a node is the top element? If a node dot next equal to null. Okay, node dot previous equal to null, then that is the top element. Okay, and next element is 1A, and the next element is 1A, and who is the previous element of A? Is C, 3, and who is next? 2. Okay, and again for node 2, previous node was A, and next node was D, and for D, previous node was B, and next node was E, and for E, next node is null. I don't have much to discuss for this. I like you to program it. Okay, copy my program and then do some practice. Okay, what I want to do, I want to implement this program using C#. I was thinking I should have C# program. Implement singly linked list, implement doubly linked list. Okay, so C# people, give attention please. So yeah, tell me, guide me, how do I do this? How can I add a new add a new project? So I do a right click on my solution. Since C# solution is a collection of projects. Okay, I will add new project, and then here I want to give my project name Doubly linked list implemented. That's it, and it will go to my project, not this one. I want it to my project workspace. CSE1322 review C# this project. Okay, I want to this within this folder. Okay, and then please okay. Okay, my doubly linked list. I got my project. Then I need to add. Do right click, and at this time I need to add an item, new item. At this time I need to add a class. What is my class name? Will be node class. The people who are taking C# lab, please guide me. Okay, I want to put this node, my doubly linked list node over there in my node class. Okay, people taking who are taking C# lab, please tell me what do I need to change? I need to change here, right? Console dot right line. Okay, this one, and okay, only one, and I need to change here, right? I need to explicitly make public, otherwise it will not get it. So I need to make public, and I need to make I need to make public here, I need to make public here, I need to make public here, and so the override is different here in C#, right? How do we do that? In C#, override is not an annotation, it is a keyword. So I need to type in public override. In C#, override is a keyword all in lowercase. Okay, and then toString, in toString, to is in uppercase. Okay. Okay, and okay, so node class is already there is a node class. Public class node. Okay, this is done. Node class, and I need another linked class, Doubly LinkedList. Okay, I need another class, Doubly LinkedList. So let me add another class. Add and new item. This will be my class, and class name will be Doubly LinkedList, and add. Okay, in Doubly LinkedList, I have to add all of these until this. Okay, so this is my Doubly LinkedList class. And again, people tell me, what do I need to do? Okay, what is wrong here? Okay, I need to do console dot right line. I need to change here. I need to change here. Too many places. I need to change here, and I need to change here. I'm sorry, too many places. I need to change here. Wow. Okay, size is not taking, right? Huh? What is my problem with size? Make public. My problem with size. Cannot assign to size because it is a method group. Okay, people who are taking C++, C#, C# lab, can you please help me? Huh?
I think it's because you have it as the name of the method.
This one? Oh, I see. So in Java, it allows to have a variable with same name and method name. But maybe I need to put S is in uppercase. If I put S is in uppercase, and if I put in S is in uppercase, it should work. Okay, and Boolean is bool, right? In Java, in C#. Boolean is bool, right? So S is in uppercase, and S is in uppercase. That I need to give a different name. And S is in uppercase. And what else? Okay, 12 places. S is in uppercase, S is in uppercase, and here system dot console dot write long, and S is in uppercase, and S is in uppercase. Okay, and two other methods. So in C sharp, we do not have this exception, right? So if this exception was for Java, then maybe we can say return. Okay. Instead of this, maybe I can say return. This, then return. Okay, and let's see, now it's good. And now lastly we need this method. And this method within programs, within my main method. Okay, again. Console dot write line. Console. Okay. Console dot read key. I usually use this one in order to get my okay, so this I need to okay, let me run this one. Let me see if I make it set as a startup program, and if I run it. Okay, it's working. I will push this code on my GitHub account, and then you can get it, C# people, and practice it. Okay. Okay. Now I have both for C#. Let me, before I forget, let me push my code. CD workspace, CD CSE1322 review C#. Git add only 4 commands. If you want to learn, if you want learn only 4 commands, then you can push your codes on GitHub. Doubly linked list added. Okay, so now my code is added. Doubly linked list code is added on this project. So if you refresh this, okay, the last commit is okay, the last commit is doubly linked list added. Okay, doubly linked list implemented. Okay, this one. Okay, for our today's topic is okay, Kiwi. So I believe this topic will be the last topic for our test 3. For our test 3, let me see a schedule. Okay, about test 3 will be 13 or 14th, right? Next month, in 2 weeks, after 2 weeks. And we will discuss until stack and QE. Okay, so QE, there will be one question from QE. Okay, it is short. It will not take a time, that much time. So I think if you give attention to any minutes, then it's fine. So in our previous discussion, in our previous lecture, we discussed stack. Stack is called LIFO type, last in first type. Okay, is data structure. So the whatever element you insert or push in a stack, that is output first. This is why it's called last in first out. Okay, by the way, the insertion operation for a stack is called push operation, and there is another close operation that is called pick. Pick operation is just to get a copy of the top element, but not delete the top element. Okay, but if you want to delete an element from a list, from a stack, you have to delete the top one. So that is called the pop operation. Okay, so push and pop operation are the two major operations for a stack implementation. Okay, practice this for your upcoming test. And by the way, in your upcoming test, you have to write actual program code, either in C# or Java. You are not allowed to write pseudocode. Okay, but if you write your program code, then we will waive some minor mistakes, as long as that does not have a huge effect. Okay, but we like you to start programming and know how to write program. That is our goal. So we are at the end of this, almost at the end of this course. Okay, by the way, there is a built-in stack class. Okay, you can use it, but we discourage to use that, and we learn how to implement our own stack. Maybe I have a program how to use single stack implementation. Okay, in my program I have a program that has how to use built-in stack. So in Java utility, the utility package, there is a stack class that is already built in for stack operations. So you in that class you can use that class to do push and pop operations. Okay, but you can see this, but in our program we need to know how to implement our own stack. Okay. Okay, today we will learn how to implement QE. A QE is kind of another kind of data structure. That is different is that it is fast in fast out type data structure. So like for instance, in our daily life we stand in queue in many queues. For instance, if you go to ride a bus or a train, if you want to purchase a ticket, the first person who goes or stand on the ticket counter should get the ticket or service first, and the second person who comes second should get the service second, right? So instead in a QE it is two-sided, like a pipe. QE is like a pipe, like is a both way two-way pipe. So in QE is that whatever you, so in stack we remember that one side was closed, but QE, if it comes from this way, it will go that way. Okay, one way exit and another way, one way entrance, another way exit. Okay, so the node who comes first For instance, if my node 1, 2, 3, and 4, okay, the first node who was inserted in the QE first, that will be deleted first, and the second one. Okay, so like stack, there are two main operations for a QE implementation, that is called in QE, that is in QE to add an element in a stack, and DQE operation, that is called remove an element from a stack. There are two major operations for QE. So add and removes from the opposite side of the internal data structure. This data structure for QE, add goes one side, remove goes. So when you want to add, you will add all the way in this side. The next element will come here. Okay, but if you remove, then this one will be first remove. Next, this one will be removed next. Okay, so this picture says the difference between a stack and QE. As we know that for a stack, we add or insertion and deletion operation goes only one end. But in QE, it goes, insertion goes one way and deletion goes another way. Okay, so the QE operation is similar to for a like a stack operation. Sorry, we have only few slides. So let me go to my program. So for Java, if you go, okay, this was a QE implementation. Okay. By the way, like stack, there is also a built-in QE in Java utility package. So you can use that QE. Is this? No, this is not stack. Okay. Oh, it has NQE. Okay, it has NQE. It's not the QE. Okay, by the way, we will learn how to implement our own QE. So like a stack and linked list, so we have similar node, almost same kind of node. So node, a node will contain data and another node. Okay, and we have this node constructor, and this is way to display a node. Okay, you can display a node by overriding the toString method as well as, so we need to use this toString method. That's it for this is very simple and same node that we used for linked list implementation and stack implementation. Anyone has any questions so far about this node class? Okay, this is in my node class. Anyone has any question? Okay, so this is our node class, and then we will have our one class QE. So like Doubly linked list, we will have two nodes. For Doubly linked list, we have previous and next, and here we will say top and tail. Whatever name you can give, okay, that is not an issue. Top means that will be my top node, and this will be, and it will be my tail node. This will be my tail side. Okay. We need these two nodes. Okay. So remember that since node will itself call in another node. So this is why we can say node.next or node.top or node.tail. Okay. and an initially constructor, when you create a new QE, then it will be empty. So this is why our top will be null and tail will be null. Okay, and how do we check that whether is empty? Okay, if we say top equal to null, then if we find top equal to null, then we will say that this queue is empty. Okay, and how can we pick or get the top element? So if I say if it is not empty, then we can say the top node's ID is top.id. Okay, similarly, if I want to pick this is the top one. If you want to get bottom node, okay, so that means we need a little bit change over here. If you want to get the bottom one, it will be not top.id, it will be tail.id. For instance, if you want to implement another method that we say bottom one, or the last one, if you say public void bottom, then is empty, there is nothing to be bottom. And one change we need to say, okay, instead of top.id we will say tail.id. Okay, and we can implement is empty method like this way, or you can do, okay, like this way. There is different way that you can do. If instead of top you can say tail. If tail equal to null, then that will show us there is nothing on the bottom. That means that the queue is empty. Otherwise, it will get the bottom node's ID is so bottom or tail. Okay, tail.id. It should work. Okay, and okay, give attention for the last 10 minutes. Okay, we will be done in 10 minutes, hopefully. And the enqueue and dequeue operation. The enqueue operation is the operation that we use to add a new node, in a queue, right? So remember that for a queue, recall that we will add through the bottom side. We will add through this side. Remember that we will add through this side. Okay. So how do we add this side? So that means here we are checking if it is empty. How can we check that if it is empty? Okay, we first create a new node, and then if tail equal to null, that means if actually the queue is empty. Checking that if queue is empty, right? So then whatever node I will be inserting, that will be my top and that will be my tail. If my queue is empty, there is no existing node in my QE, then whatever element I add in my QE, that will be my top and that will be also my tail, head and tail, right? So this is why I am doing top equal to node and tail equal to node. Okay, but if not, that means I have at least one element in my QE. In that case, where I will be adding new element, I need to create a space. Where I will be creating a space after my existing node. How can I create an existing node? I can say tail.next. If I say tail.next, I will come to this position. I will get this position. And then at that position, I will put my node. Whatever my node ID and data, that data ID and data will be inserted here. Okay. So this is the technology that we say tail dot next equal to node, and whatever node I added over here, previously my tail was this one, and this one will be, the new one will be my tail. Two things, okay, remember that you need to do two things. Let me do side by side. Okay, you need to create a space tail.net equal to node. That means you have to create a space. By how can I create a space? Just I put this as my previous tail, for instance, tail.next, then I will get a space. Okay, because remember that my tail is a kind of node, right? Tail is a kind of node, so it has next. Remember that my tail is a kind of node, so node did have next. So this is why I am able to say my tail.next. Okay, and since it's node, it can carry a node, it can hold a node ID, because my node class had a constructor that can take this. Okay, and finally I need to update my tail so that I can add another element next time. Okay, so if you forget to do this, then your program will not be completed. The another element will override this position. There will be an issue. Okay, so this is the enqueue operation. Anyone has any question? Okay. So now dequeue operation. So think about that dequeue operation, it needs to do other side, right? So dequeue operation, it needs to do through other side, through this side, through this side. So what do we, in order to dequeue, whenever you delete a node from either a linked list or a stack or a queue, we are not actually deleting this node. What we are doing, we are unlinking. Okay, so how do we unlink? For instance, this one. So previously this node was my top node, right? So if I say this my top, if I say this, no, this is not my top, this will be my top. Then this top was unlinked. So how can I say that? So first of all, I need to say, so only this line. Main line is this line. I say top equal to top.next. But here I have added this line just to give which element is being deleted. So this element, I say the node with ID and name is deleted. So this is why I want to just, if I want to give a message that which ID is being deleted, in order to keep that operation, I just need to keep this, but the main operation is this. By doing this, what I'm doing, I am changing my top. I'm unlinking this. This was my previous top. No, this node will be stop. Then will be stop. Next. So then, if I want to delete two nodes, then what is the technique? Yes, I can say top.next.next. If you say top.next.next, then it will come, your top will be this one, 3, right? Maybe in a data structure course, you will get this kind of question. Not in our course, because we are discussing just introduction. Okay, then, but this is the check for empty check. For instance, if my stack is empty, right? If my stack is empty, right, then there is nothing to delete. Okay, how do I check that this is empty? If top equal to null, okay, then this is actually top equal to null. I just give this message. You can say tail equal to null. You don't need this also actually, then just return. If it is empty, that means how do I say it's empty, right? It's top, there is no top. If top equal to null, or tail equal to null. But since we in case of delete DQ operation, we go through front side, okay, front end. So then we should is wise to use top. You could say tail equal to null. That's it. Tail equal to null, that means empty as well as. So these are my stack implementation, and then if you create a stack, and then like you can add an element like NQ with NQ operation, and you can add another element, and you can add more elements, and you can do pick. Maybe I can do my q dot, I added a new method bottom. You can do bottom also, and there are DQ operations. So at the way, if I have more DQ operations than my element, then you should say there is nothing to delete, right? So let me run this program. Okay, it was working. The bottom element was node is 5, right? It is showing my bottom element as well as, and it is showing my top element, and I have all the elements. And since I have deleted all of these elements, but I have more DQ operations, so for these DQ operations it is showing me there is now node to delete. Okay, and let me add one more element and see if I get this here. If I add one more element, like not 5, not maybe 50, and maybe GG, and let me see if it shows my top and bottom. Okay, for only one node, top node ID is 50 and bottom node ID is 50. At this point, all previous nodes are deleted. So I have only one, the last one remains that I have already. So it is showing my peak. That means my ID is 50 and bottom is 50, and then ID, this node name ID is 50 and name is GG. Anyone has any question? Okay, for your upcoming test, you will have questions for implementing stack, QE, single linked list, and you will have question from recursion. Okay. So please practice. Okay, so this course is mainly depend on your success in this course will depend on your practice. The course content whatever I could finish in one day or one night. If I continue whole night, then I can finish a whole course, but that will not work for you, right? We have to go little by little, step by step. Let me see if I have this code in my C# implementation. It is called QE implementation. PQR. Okay, implement QE, it has this one. Okay, I have my Q class is empty method. I have pick maybe, but I do not have the bottom method. Just I add it over here. Let me add the bottom method. Bottom method I can add over here. So people who are taking C# lab, please help me. How do I need to change here? Console. Getting lazy. I don't like to type it. Okay. That's it. Right? So then in my Q implementation, okay, implement QE. Okay, this is my program, implement QE. Okay, so my programs, I can say pick, I can say my Q dot bottom. And I added at the end, I added another QE, another one, that is maybe 50 and GG, 50 and GG. Okay, that's it, and I will add this in my. I forgot semicolon. Oh, thank you, thank you. I did not work. So git add, git commit, QUE, UE implementation updated. Okay. Oh, I did not save it. Okay, thank you everybody, thank you so much, and have a good evening.